Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about average rates of change.
Minute Math, when you need help you use Minute Math.
We're given our function right here, y equals x squared minus x plus 1, and we have to find the average rate of change over the interval from 0 to 3. And we have our function graphed right there. Now, when we find the interval from 0 to 3, those are the x values, and we need to find the corresponding y values for them. So let's go do that. Let's plug 0 into our equation. 0 squared minus a 0 plus 1. Well, what does that come out to be? Well, 0 squared minus, 0 squared is 0, minus 0 is 0, and just 1. Well, let's do the same thing for 3 now. 3 squared minus a 3 plus 1. 3 squared is a 9, minus a 3 is a 6, plus the 1 gives us 7. So now we have to use our formula for the average rate of change, our delta y over our delta x. Change in y over change of x. 7 minus 1 over 3 minus 0. 7 minus 1 is a 6, and 3 minus 0 is a 3. And 6 divided by 3 is a 2. So our average rate of change for this function is over the interval from 0 to 3 is 2. We're given this problem right here. Y equals a negative 1 over x minus 2 on the interval from negative 3 to negative 2, and that interval is where we have to find the average rate of change. Now we have our graph here that represents this function, and we're going from negative 3 to negative 2. So let's go find the y values that occur at negative 3 and negative 2. We do that by taking our function, negative 1 over, and instead of x, put a negative 3 in for x minus 2. Well, what does that come out to be? Well, negative 3 minus 2 is a negative 5. Double negative makes it a positive. So this comes out to be a positive 1/5. Do the same thing with the negative 2 for the x. Negative 1 over a negative 2 minus 2. And what does that come out to be? Well, a positive 1/4. So we have a 1/5 and 1/4 as our y values here. So let's use our formula here for the average rate of change. Delta y over delta x is a change in y over change of x. 1/4 minus the 1/5 over negative 2 minus a negative 3. Okay? Well, 1/4 minus 1/5, really we combine those fractions, okay? Combine the fractions, find a common denominator, is the same as 5 over 20 minus 4 over 20. And that's going to be over, well, it's double negative, turns a positive, and then we have a positive 1. Don't really need to care about dividing by 1, and 5 over 20 minus 4 over 20 is a 1/20th. And so our average rate of change over our interval from negative 3 to negative 2 is a 1 over 20. We're given this problem right here, y equals a negative x squared plus x plus 2, and we have to find the equation of the secant line over the points negative 2, negative 4, and 1 comma 2. Well, like any finding 2 points there, we need to find, well, the slope first. Now, we have our graph here, we can kind of see the secant line there, we're just finding that secant line. So slope here, well, our slope is m equals a y2 minus y1, so 2 minus a negative 4, over 1 minus a negative 2, x2 minus x1. And that comes out to be a, well, 6 over 3, and that's just a 2. And so my slope here is 2. Well, now we have to find the b value. So we use the y equals mx plus b formula, y equals mx plus b, and let's put in the values that we know. Well, we know our slope is 2. We have 2 for a slope, and let's go put in some x values and y values from a coordinate point. Now I like to find what I think is the easiest one. I think it's 1 comma 2. 1 for x and 2 for y. We solve this. We have 2 equals 2 plus b, and well, subtract 2 to both sides. b equals a 0. So if b equals 0 and m equals 2, our equation of our line here, the secant line, is y equals 2x, and that is our final answer. We're given this problem right here. Y equals a negative 1 over x from the interval we're going to find the equation secant line over the given points, 1 comma negative 1, and 3 comma negative 1/3. Well, our graph here shows what that secant line looks like, so we just need to find the equation of it. First, we have to find the slope. So m equals, our slope here, is equal to our y2 minus y1, so negative 1/3 minus a negative 1, over x2, 3 minus x1, 1. Now let's keep on going trying to find the slope. Negative 1/3 plus a positive 1 is a positive 2/3. 3 minus 1 is a 2. 2/3 divided by 2 is a 1/3. And so our slope here is 1/3. So now let's go find the b value. So we have our equation on the line, y equals mx plus b, and let's put in what we know. Let's pick a coordinate point, 1, negative 1, I think it's easier. So y is a negative 1, and our slope is 1/3, and a positive 1 here for our x value, plus b. Negative 1 equals 1/3 times 1, which is 1/3, plus b. Subtract a 1/3 to both sides, and b comes out to be a negative 4/3. So we have our slope, we have our b value, or y-intercept, and so our equation of the line here, put it right here, is y equals a 1/3 x minus 4/3. And so the equation of the secant line through these 2 points is y equals 1/3 x minus a 4/3. We're given this problem right here, y equals x squared plus 2, and we need to find the average rate of change over the interval from negative 2 to negative 3/2. Well, these are the x values, and I want to find the corresponding y values that occur here. So let's take negative 2 and plug it into our equation. Negative 2 squared plus 2, and that comes out to be a positive 6. Negative 2 squared, positive 4, plus 2 is 6. Let's do the same thing with the negative 3/2. Negative 3/2 squared plus 2. Negative 3/2 squared comes out to be a 9/4, and then we add a 2 to that, and that comes out to be a 17/4. Alright, so now we have the corresponding y values. So we need to use our formula here. Our delta y over our delta x is equal to our y2, 17/4, minus y1, 6, over negative 3/2 minus a negative 2. Okay? Well, what does this come out to be? Well, 17/4 minus a 6 comes out to be a negative 7/4 as a fraction. The denominator, negative 3/2 minus a negative 2 or plus a positive 2, comes out to be a positive 1/2. Negative 7/4 divided by a 1/2 is a negative 7/2 here. And so our final answer for the average rate of change over the interval from negative 2 to negative 3/2 is a negative 7/2. We're given this problem right here, y equals 2x squared minus 2x plus 1, and we define the average rate of change over the interval from negative 1 to negative 1/2. Well, these are our x values, and so we need to find the corresponding y values there. So I'm going to take my negative 1 and plug it into my equation here. 2 times a negative 1 squared minus 2 times a negative 1 plus 1. And that comes out to be, when we do it all, a positive 5. So it's the same thing with the negative 1/2. 2 times a negative 1/2 squared minus 2 times a negative 1/2 plus a 1. And that comes out to be a 5/2. So we have our two y values. Let's use our formula here. The change in y over the change of x is equal to y2, 5/2, minus y1, 5, over the change in the x values, negative 1/2 minus a negative 1. Don't forget the double negative there. Well, 5/2 minus 5 is a negative 5/2. Negative 1/2 plus a positive 1 is a positive 1/2. Negative 5/2 divided by a 1/2 is a negative 5. And so our average rate of change here from negative 1 to negative 1/2 is a negative 5. We're given this problem right here. Y equals a negative 1 over x plus 2, and we have to find the average rate of change over the interval from negative 1 to negative 1/2. Well, these are our x values, and we want to find the corresponding y values. So I take my function, negative 1 over, and instead of x, I'm going to put the negative 1 in plus 2. And this is going to help me find the corresponding y value. Well, negative 1 divided by negative 1 plus 2 is just a negative 1 when it's all said and done. Let's do the same thing with the negative 1/2. Negative 1 over a negative 1/2 plus 2. That comes out to be a negative 2/3 as a y value. So now we have our two y values. We can use our formula. Our formula for the average rate of change, the delta y over a delta x, is equal to negative 2/3 minus a negative 1, the change in the y's, over the changes of the x's. Negative 1/2 minus a negative 1. Well, negative 2/3 minus a negative 1, or plus a positive 1, is a positive 1/3. Negative 1/2, again, minus a negative 1 plus a positive 1 is a positive 1/2. And 1/3 divided by a 1/2 is a good old 2/3. And so our average rate of change over the interval from negative 1 to negative 1/2 is a positive 2/3. We're given this problem right here, y equals 2x squared plus x plus 2, and we define the average rate of change over the interval from 0 to 1/2. Well, these are our x values, and we need to find the corresponding y values. So let's plug these values into our equation. 2 times 0 squared plus a 0 plus a 2. What does that come out to be? Well, just good old 2, right? The zeros kind of cancel everything out. Same thing with the 1/2. 2 times a 1/2 squared plus a 1/2 plus a 2. Well, that comes out to be a good old 3. So now we have our y values, we have our x values here that correspond with it. Let's go find our average rate of change, our delta y over our delta x. The change in y, 3 minus 2, over our change of x, 1/2 minus 0. 3 minus 2 is a 1, 1/2 minus 0 is a 1/2. 1 divided by 1/2 is a 2. And so our average rate of change over the interval from 0 to 1/2 is 2. We're given this problem right here, y equals a negative x squared minus 2, and we will find the equation of the secant line over the interval of 1, negative 3, or the points 1, negative 3, and 3/2 negative 17 over 4. Well, first thing with finding the equation of line is we have to find the slope. So our slope here is equal to our y2, negative 17 over 4, minus our y1, negative 3, over x2, 3/2, minus x1, 1. So, I did the hard work for you. Negative 17 over 4 minus a negative 3, or plus a positive 3, is a negative 5/4. 3/2 minus 1 is a 1/2. Negative 5/4 divided by a 1/2 is a negative 5/2. And so our slope here is negative 5/2. Now, we have to find our b value. So we use our equation, the y equals mx plus b, and let's put our slope of negative 5/2 in. And for x values, or xy, let's pick an easier one. I think it's the first one. X is 1, we have plus b, and our y value is negative 3. And so now let's solve for b. Well, 1 times negative 5/2 is 5/2, or negative 5/2, sorry. And then we add that to both sides, and b is by itself, and negative 3 plus 5/2 is a negative 1/2. And so our b value is negative 1/2 here. Our m is negative 5/2, so our equation of our line is y equals a negative 5/2 x minus 1/2, and that's the equation of the secant line that goes through the given coordinate points. We're given this problem right here, y equals 1 over x plus 3, and we have to find the equation of the secant line to the given points, negative 1, comma 1/2, and negative 1/2, comma 2/5. First step, we got to find the slope. So our slope here is equal to our y2, 2/5, minus our y1, 1/2. And that's over our x2 minus x1, negative 1/2, minus a negative 1. Well, I did the hard work here for you, and 2/5 minus a 1/2 is a negative 1/10. Negative 1/2 minus a negative 1, or plus a positive 1, is a positive 1/2. Negative 1/10 divided by a 1/2 is a negative 1/5. And there we have our slope. So we have the equation of a line, y equals mx plus b. And we know our m value is negative 1/5. Let's go pick a coordinate point for our x and y, and I think the first one's easier. X value is negative 1, have the plus b there, and our y value is 1/2. And now we're actually going to solve for our b value. Well, negative 1/5 times a negative 1 is a positive 1/5. Subtract that to both sides, and b is now by itself, and we get b equals a 3/10. So our equation here, or the secant line, we have y equals our slope, negative 1/5 x plus a 3/10. So our final answer here for the equation of the secant line is y equals a negative 1/5 x plus 3/10. We're given this problem right here, y equals 1 over x minus 1, and we have to find the equation of the secant line through the points negative 2, negative 1/3, and negative 3/2, comma, negative 2/5. Our first thing we always want to find is a slope here. So our slope is equal to our y2, negative 2/5, minus our y1, a negative 1/3, over our x2, negative 3/2, minus a negative x1, 2. All right, well, let's go find the numerator here, and I did the work for you. Negative 2/5 minus a negative 1/3 or plus a positive 1/3 is a negative 1 over 15. Our denominator, negative 3/2 minus a negative 2 or plus a positive 2 is a positive 1/2. And negative 1 over 15 divided by a 1/2 is a negative 2 over 15. And so that's our slope here. Now our formula for our equation of line, let's go with y equals mx plus b. We found our slope. So our slope is negative 2 over 15 here. Let's pick a coordinate point for our x and y value, and I think the first one's easier. X is negative 2, and our y is a negative 1/3. And don't forget the plus b. And now let's solve for b. We have negative 1/3 here, and negative 2 over 15 times a negative 2 is a positive 4 over 15. We add the b. We subtract a 4/15 to both sides, and b is now by itself at a negative 3/5. Well, we have our slope, we have our y-intercept, we can have the equation of line. Y equals a negative 2 over 15 x minus a 3/5, and that is the equation of our secant line. We're given this problem right here, y equals a negative 1 over x, and we have to find the equation of the secant line from the points 1, negative 1, and 3/2, negative 2/3. First thing we want to do is find the slope. Our slope is our y2 minus y1 over x2 minus x1. y2, negative 2/3 right here, and y1, a negative 1. Same thing with the x, 3/2 minus a positive 1. Well, negative 2/3 minus a negative 1 or plus a positive 1 is just a positive 1/3. 3/2 minus 1 is a 1/2. 1/3 divided by 1/2 is a 2/3. So our slope here is 2/3. Let's go find our b value now. We know we have y equals mx plus b, and we know our slope here is 2/3. We just found it. Well, let's go plug in our x and y value and find a point that's easiest, and I think it's the first one. Negative 1 for y and positive 1 for x. Well, 2/3 times 1 is 2/3. Subtract a 2/3 to both sides, and we get our b value to be a negative 5/3. So with b being negative 5/3 and our m being 2/3, our slope, y equals 2/3 x minus 5/3 is the equation of our secant line. We're given this critical thinking question. The police have accused a driver of breaking the speed limit of 60 miles per hour. As proof, they provide 2 photographs. One photo shows the driver's car passing a toll booth at exactly 6 p.m. The second photo shows the driver's car passing another toll booth 31 miles down the highway at exactly 6:30 p.m. Does the photo evidence prove that the driver broke the speed limit during this time? So what we want to find here is really find the driver's average speed. And that's going to be the change in the distance, so our delta d over our delta t. Okay? And that's going to give us his average speed. Well, the driver traveled a total of 31 miles. That's the change in distance, 31 miles. Now the average time, we know, well, miles per hour, that's what we're measuring here, and they traveled 30 minutes. 30 minutes is equal to 1/2 of an hour. Okay, so we have 1/2 here, hours. It took them to travel 31 miles. Well, 31 divided by 1/2, or 0.5, is 62. And that's 62 miles per hour we have here. So our motorist traveled an average speed of 62 miles per hour over this interval. So yes, the motorist did break the speed limit of 60 miles an hour. If the average was 62 miles per hour, at some point the motorist must have traveled over 60 miles per hour and therefore breaking the speed limit. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.